Look at this robot. It can run, fight, dance, carry objects, and recover after losing its balance. But the movement isn't the most important part of this story. Look behind it. The motors, the batteries, the cameras, the factories, the suppliers, and thousands of engineers trying to make the next version cheaper before the current one is even old. That is where China's advantage becomes much more interesting. Because the race for humanoid robots may not be decided by who builds the smartest prototype. It may be decided by who can build millions of useful machines. Before talking about humanoids, look at ordinary industrial robots. In 2024, factories around the world installed about 542,000 industrial robots. China alone installed roughly 295,000 of them. That is 54% of the entire global market. The United States installed about 34,200 in the same year. China now has more than 2 million industrial robots operating inside its economy. So when a Chinese company wants to test a new motor, reducer, camera, battery pack, or control system, it isn't building inside an empty ecosystem. It is building on top of one of the largest automation infrastructures ever created. Humanoids are entering an industrial system that already knows how to manufacture robots. Now look inside the humanoid itself. A humanoid needs electric motors, precision reducers, encoders, bearings, batteries, cameras, computers, wiring, machined aluminum, and increasingly sophisticated hands. Analysts estimate that China controls roughly 63% of the key companies in the global humanoid supply chain. That changes the economics. Unitree launched its G1 in 2024 at a starting price of 99,000 yuan. A year later, it introduced the smaller R1 starting at 39,900 yuan, roughly $5,566 at the time. That doesn't mean the R1 can replace a human worker. It means the hardware learning curve is moving very quickly. Cheap robots create more experiments. More experiments create better hardware, and better hardware creates even cheaper robots. Hardware alone won't make these robots useful. They need models that can understand instructions, recognize objects, plan movements, and recover when reality refuses to behave like a simulation. This is where the comparison with the United States becomes more complicated. America still has enormous advantages. According to Stanford's 2026 AI Index, U.S. companies produced 59 notable AI models in 2025, compared with 35 from China. American private AI investment reached almost $286 billion. China's measured private investment was about $12.4 billion. Model performance tells a different story. By March 2026, Stanford found that the performance gap between the leading American and Chinese models had narrowed to only 2.7 percentage points. China no longer needs to start this robotics race with weak AI. And physical AI has another problem that money alone doesn't solve: data. A language model can learn from enormous amounts of text. A robot needs to learn what happens when a slippery cup moves inside its fingers, when a box is heavier than expected, when a human walks into its path, or when a grasp simply fails. That requires real machines doing real tasks. In June 2026, China's Ministry of Industry and Information Technology launched a program specifically designed to put humanoid robots and embodied AI into real production and everyday environments for continuous training. Factories are becoming laboratories. Every failed grasp can become another training example. Every deployment can generate more physical world data. That feedback loop may be more important than another impressive backflip. This is already moving beyond laboratory prototypes. Counterpoint estimates that China accounted for more than 4/5 of global humanoid installations in 2025. In that same year, Unitree and AgiBot each shipped more than 5,000 humanoid robots, according to Omdia. At the World Robot Conference in Beijing this August, more than 300 exhibitors brought over 2,000 robotic exhibits, with more than 150 new product launches. Those numbers matter because robotics improves through iteration. Build one robot and you learn about one robot. Build thousands and you discover bad bearings, overheating motors, broken cables, unreliable hands, software crashes, and thousands of edge cases that never appeared in the lab. Manufacturing is also a form of research. There is one problem. Today's humanoids are still nowhere close to replacing people across general work. They struggle with dexterity. They make simple mistakes. Many demonstrations still depend on teleoperation, carefully prepared environments, or repeated attempts. And even Unitree's founder says the industry's true ChatGPT moment, a robot that can enter an unfamiliar environment and reliably understand what to do, could still be years away. China has scale. It does not yet have general-purpose robotic intelligence. Nobody does. But this is why China matters. It doesn't have to invent every breakthrough first. It needs to turn breakthroughs into motors, batteries, hands, factories, data, and affordable machines faster than everyone else. America still leads in capital and many frontier AI systems. China's advantage is different. It can connect intelligence to manufacturing. And if humanoid robots become the next mass-produced computing platform, the most important factory of the AI age may not be a data center. It may be a factory building the bodies that AI will live inside.